Welcome back, everybody. Number five. Number five actually should have gone before number four. They want to know the intersection, and again, we talked about that in number four. You just multiply those together, so you do 0.7 times 0.5. Number six, tree diagrams, and this is going to help you guys list possibilities. They say there's two blue on a die. There's two sides that are blue and four sides that are red, right? And so what you guys can do, hopefully you can see this whole thing. You're going to roll this thing 3 times, right? So with the first roll, you can either roll a blue or a red, right? You take this die, you roll it, blue or red, right? Now for your second roll, again, you can either roll a blue or a red side, right? These are separate things. You roll the dice, you record the color. It can be blue or red each time. There are 2 more red faces though than blue faces, so the probabilities will be a little bit different. Same thing down here. If you roll a red first, again, in your second roll you can roll a blue or a red, right? Then they say that you roll it 3 times, right? So your third roll, again, you rolled a blue, and then you can roll a blue or red, and you can roll a blue or red, blue or red, blue or red. And this gets super time consuming if you have like a million things, like I don't know, like if they weren't blue or red, if they were a 1 through 6, right? You could roll a 1 through 6. I think we talked about this way back when. But you're gonna have all these outcomes over here, right? So you could roll on these die, you could roll blue, blue, blue. Right, next one is blue, blue, red. You just follow all these branches. That's why it's called a tree diagram. Then you have blue, red, blue. And this would be way more helpful if I actually had the colors, markers. Sorry about that. Then blue, red, red. Then red, blue, blue. Red, blue, red. Red, red, blue. And then red, red, red. And I think we did this last time too, right? When you roll 3 die, there's 2 choices each time. It's either blue or red, right? You multiply all these together. That means there's 8 different ways that this can happen. And these are the 8. These are actually them listed, right? You roll a die. These are the ways that they can come out. Now, as far as the probabilities, it's not 50-50. It's not heads or tails, right? Because there's 2 more red sides. So each time you roll the die, it's 2 out of 6, because there's 6 different colors here, right? It's 2 out of 6 or 1 out of 3 for blue, and then 4 out of 6 or 2 out of 3 for red, right? There's twice as many reds as there are blues. So 2/3 is twice as big as 1/3, right? So for each of these probabilities, right, blues are always 1/3. So you have a 1/3, 1/3, 1/3. Then reds are 2/3, and we're going to put these on each of the branches. Blue is 1/3, red is 2/3, blue 1/3, 2/3, 1/3. I know this is getting really cramped. 2/3, 1/3, 2/3, right? So the probabilities, these are all independent, right? When you roll 1 die, it doesn't matter what you got on there. The next time you roll, it has no difference what you roll. Like if you rolled a blue, that doesn't mean you're going to roll a red next time. Doesn't matter. So for each of these branches, you find the probability by multiplying all the probabilities together. So it's blue, blue, blue. That's 1/3, 1/3, 1/3. That's 3 times 3 is 9 times 3 is 27. So you have a 1 out of 27 chance of rolling 3 blues in a row. And if you think about it, that makes sense, right? Because blue, there's only 2 out of 6 sides that are blue. So to roll all 3 of those, it's not going to happen very much, right? Blue, blue, red would be blue 1/3, 1/3, so that's 1 out of 9, and then red is 2/3, right? 1/3, 1/3, it's 1 out of 9, that's 2 out of 27. That's not going to happen a lot. The more reds you have, the more your probability is going to be, right? Because there's 4 sides that are red. The next one's blue, blue. Oh no, what is it? Where am I at? Blue, red, blue. So that's 2 out of 27 again, right? Anything with 1 red and 2 blues will be 2 out of 27. Now, blue, red, red is going to be a little bit higher, right? That's going to be 4 out of 27. 1 times 2 times 2 times 27 on the bottom, right? All these are going to have 27 on the bottom. Next one, red, blue, blue is going to be 2 out of 27. Remember, the only 1 red, 2 out of 27. Next one, 2 reds. That's going to be 4 out of 27. Right? Red, red, blue. Again, 4 out of 27. And now red, red, red. This is going to be the highest one. 2 times 2 is 4 times 2. That's 8 out of 27. Right? These are all the possibilities. Now, if you add all these up fraction-wise, right, it's still, just like with our Venn diagram, has to add to 1. So 1 plus 2, that's 3, 5, 9, 11, 15, 19, 27. 27 out of 27. So all of these will add to 1, right? And so it's just a way of organizing the probabilities, and if we were in class and this was normal times, I'd have different colors up here and you guys could see this. But they want to know this one right here, red, red, blue, right? So you just go through all these. Where's red, red, blue? Red, red, blue is this one right here, right? So the probability of rolling a red, red, and a blue is 4 out of 27, and that would be your answer for that one. All right, thanks guys.